So this is just a simple example, mostly to showcase the ebook part of our book. So I'm going to share my screen. All goes according to plan. Boom. Okay. So this is just a brief tutorial. This from the textbook, and probably showcases why it is that I like this book. So these animations are built in a software package called Mathematica. It's the same package that produced Wolfram Alpha, but Mathematica has been around a long time. And these animations are called manipulates. So you might hear me use the word animation, you might hear me say manipulate, and they're the same thing. And so what I simply want to point out is that if we have a point, we can locate it coordinate-wise by the radius, its distance from the origin, except for we got to give the origin a new name. Origin is so old school. So now we call it the pole. And then the angle that's swept out from the positive x-axis, which now we need to give a new name as the polar axis. So here the coordinates are 1, pi over 12, so that would be a distance of 1 from the pole. Angle swept out is pi over 12. So adding to the radius, now we're at 2 pi over 12, so we're gone twice as far out. Angle is the same. We could change our angle. Now we're at pi over 6. When things get kind of interesting, when your thetas get, or sorry, when your r's are negative. So if r is negative, then now we're still going out that pi over 6, that positive positive theta ray would tell you what happens if r is positive. But since r is negative, we pop through on the dashy part of the curve. So for example, what this means is you can locate points with multiple representations. Let me say that again. Points have multiple representations. So this point Q could be written as 1, 5 pi over 4, because it's distance of 1 from the pole. The angle being swept out is 5 pi over 4. Same point could be reached by rotating the other direction. So now your angle is negative 3 pi over 4. Or we could have a small angle of pi over 4, but a negative radius. So all three of those representations will give you the same point on the grid. So this should be, I hope, old school. This is just a reminder of stuff from trig. It's been a long time, but mostly I'm using it to showcase how the manipulates work. All of these are available in the ebook, and a huge part about why we're switching texts and we're using MyLabs this quarter is because I want you to have access to this ebook. So let me switch over to my other monitor. So I want to express this equation in polar coordinates, and we have to remember the important formula that we'll need is that x is equal to r cosine theta, and y is equal to r sine theta. So if we look at this sine theta that's here, there, we should be able to replace our sine theta with, what would that be? Y over r. Good news, we can find a common denominator. So this is going to be 4 over 1 plus y all over r, but we could invert and multiply, so it'll be r equals 4r over 1 plus y. And then I think we could divide both sides. Yeah. Divide both sides by r. feel like I did something funny. Oh, I know what I did. Sorry, call me on it. What did I miss? I missed the R that's right here. So let me go there. So R plus 4R over R plus Y, we could multiply, we could multiply both sides by R plus Y to clear our denominator. So we have R squared plus RY, I'm solving it differently than I did in my notes, equals 4R. So we had R squared plus RY equals 4R, common denominator of, or common factor of R. So we have R plus Y equals 4. And at this stage, I want to get the R stuff on one side and get everything else on together on the other side. So we have R equals 4 minus Y. Here you could be like, oh, we could go back to the theta stuff, but we don't want to go back to theta. And so at this stage, we think to ourselves, we're like, wait a second, we remember that R squared is equal to X squared plus Y squared. And so taking advantage of that thought, we're going to square both sides. So we get R squared is equal to 4 minus Y quantity squared. So I squared both sides. And we can replace the R squared with an X squared plus Y squared equals 4 minus Y quantity squared. At this stage, if we wanted to, we could work through it and go through and solve for Y. And at the end of the day, you end up with Y equals negative 1 over 8 X squared plus 2. The work in here is just algebra. The question was asking us to simply express this equation in polar coordinates, or this express in polar coordinates this thing and turn it into rectangular coordinates. We've done it we put it in rectangular coordinates, so we're done. Not terribly exciting.
One question.
Go ahead.
Those coordinates you speak of, is that similar to Cartesian?
These are Cartesian. So this is Cartesian or rectangular. These ones up above would be polar coordinates. Did that answer your question?
Yes, thank you.
Cool. Other questions?
Wait, so can you go through the steps again for like getting to the answer again? Because I got confused with like where'd all the R's come from?
Ooh. Okay. Sure. Let me go back to the beginning. So we were given this expression in polar coordinates, and we were asked to express it in rectangular coordinates. Okay. So to do that, I'm going to replace my sine theta. We know that y equals r sine theta. That's our formula that we remember from the past, we hope.
Mm-hmm.
And so we can solve this thing for sine theta. So the sine theta becomes a y over r. So we have r equals 4. And so then we can find a common denominator, which would be r. And so with that common denominator in place, we end up with same r equals 4r over r plus y.
Okay.
Clear your denominators by multiplying both sides by r plus y. So now you have the 4r equals r times r plus y. And
Okay.
expand it out.
So, Dusty,
Go
so
ahead.
the step you canceled out, it is correct. It's just in denominator, it's r plus y instead of 1 plus y.
Exactly, it's r plus y. Exactly.
Yeah.
Yeah.
And everything is correct. Yep.
And then it would have saved me the step where then I have to cancel
Yep.
the r later. Yep, you're correct. Yep.
I have a question.
Go ahead.
If I hit share screen, does that just replace my little window, or does it replace what you're doing? Because I have like a little thing that could help explain that.
So I can let you share. I have to allow it though.
So
Okay, go try to share your screen. We'll all see your stuff.
that I don't know if everyone can see it. So it's a triangular proof right there why you can do the x equals r cosine theta. That's where it just comes from. Because if you look at this piece here, it shows that every Cartesian point can be expressed with a polar point, and then these right here, I don't know if you can see my cursor moving around, but that's where the r's come from.
Yeah, that's nice. Thank you. Yeah, that totally explains where those formulas come from. I appreciate it. That's cool. Do you want me to walk through the rest of the derivation, or?
I understand now. Thank you.
Sense? Perfect. Perfect.